The beautiful problem that we will try to solve in this video is taken from a book named The Art and Craft of Problem Solving. The problem goes like this. Imagine the scenario that you are the host of a party where you invited 10 couples. So along with you and your partner, in total there are 11 couples. Each of the small circles represent each person in the party. You asked everyone present, including your partner, how many people they shook hands with. It turned out everyone you asked shook hands with different number of people. For example, let's say this person didn't shake hands with anyone. What a snob. This person, let's say, shook hands with only one person. This person shook hands with 2 people, this person with 3 people, and so on. Given that none of them shook hands with their own partners, which makes sense as they came together to the party in the first place, the question is how many people your partner shook hands with. At first, the problem could seem impenetrable. How on earth are we supposed to approach this? One of the things I like about this problem is that to solve this, you don't need any advanced knowledge of any mathematical discipline. What it requires is ingenuity and the patience to investigate. Speaking of investigation, the first step of solving any problem is spending a lot of time investigating the problem. So let's investigate this problem together. We have 11 couples or 22 people in the party. For this problem, 22 is a considerably large number. If we want to make a diagram of who shook hands with whom and so on, it will be a big mess. So what can we do about it? Well, one of the most effective strategies in problem solving is the make it easier strategy. The strategy is very simple. If the given problem is too difficult, try to solve an easier version of that problem. While doing that, maybe you will find some sort of patterns or discover some insights that will help you to solve the original problem. That's the whole idea. For this problem, it is very likely that the number 11 or 22 are not special. So instead of working exactly with 11 couples, let's reduce the number to make it easier. Let's say we have only 3 couples in the party, including you and your partner. All the other conditions of the problem will remain same. Now let's assume that these 6 small circles represent the 6 people in the party. This one is you, the host of the party, denoted by H. Now you asked all these 5 people how many people each of them shook hands with, and you found out, as given in the question, each of them shook hands with different number of people. But what is the maximum number of handshakes a person can have? Well, other than that person, there are 5 more people in the party. But that person didn't shake hands with his own partner, as given in the question. So the maximum number of handshakes a person can have is 5 minus 1 or 4. So the handshake number for each of the 5 people ranges from 0 to 4. Let's call these 5 people P0, P1, P2, P3 and P4 respectively based on their handshake number. This is the diagram that represents the whole scenario, where each of the line segment between the vertices represent a handshake between them. Now let's look at the 2 people with extreme handshake numbers, P0 and P4. P0 didn't shake hands with anyone. On the other hand, P4 shook hands with everyone except his or her own partner. That means everyone who is not P4's partner has non-zero handshake number, which implies that P4 and P0 must be partners. Now let's look at P3. P3 shook hands with everyone except P0 and P1. But you already established that P0 is the partner of P4. That means P1 and P3 are also partners, which also implies that the only remaining person, P2, must be your partner, who shook hands with exactly 2 people. So what we are getting here is that when you invite 2 couples in your party, your partner shakes hands with 2 people. I believe some of you who are comparatively quick have already formed a hypothesis. Just to make it even clearer, let's see what happens when you invite only 1 couple. Now it's not a party anymore, it's more like a double date. This is the diagram that represents the scenario, where H is you, the host. Here P2 and P0 are clearly partners, as P2 shook hands with everyone except P0, which implies that in this case, P1 is your partner who shook hands with 1 person. So when you're inviting 1 couple, your partner shakes hands with 1 person. I hope now all of you see what is going on here. Let's write it as a generalized hypothesis. If we invite n couples, and if no one shakes hands with his or her partners, and if each of the 2n plus 1 people you asked shook a different number of hands, then your partner shook n hands. Now the question is, how can we prove that this is true for any natural number n? Some of you probably have already guessed it. Yes, we are going to use a proof method called mathematical induction. For those of you who don't know how mathematical induction works, here is a brief overview. The idea of proof by induction stems from one of the defining properties of natural number known as the principle of mathematical induction. The idea is that if you want to prove that a certain statement Pn is true for all natural numbers, it is enough to fulfill these 2 steps. 1. It is true for n equal 1, and 2. If it is true for n, it is also true for n plus 1. It is easy to see why it works. Let's say we proved that a particular statement is true for n equal 1, and we also proved that if it is true for n, it is also true for next integer n plus 1. Combining these 2 steps, we get that the statement is true for 1 plus 1 or 2. Similarly, it is true for 2 plus 1 or 3. By similar reasoning, it is true for 4, 5 and so on. So it is true for any natural number. A good analogy for it is the domino effect. Consider a bunch of dominoes standing in a row. Now if we knock down the first domino, given that all the dominoes will strike the next one while falling, it will start a chain reaction that will eventually knock down all the dominoes. Here you pushing the first domino is analogous to proving a statement for n equal 1. And the fact that each domino will always strike the next one is analogous to proving that if the statement is true for n, it is true for n plus 1. So based on the domino effect, you can intuitively see how mathematical induction works. Now that we know how mathematical induction works, we are ready to see the general solution. We have already seen that the hypothesis is true when n equal 1, that is when you invite only 1 couple. So that means if we can prove that the hypothesis being true for n implies that it is true for n plus 1, we are done. Now let's see what happens when you invite n plus 1 couples. Including you and your partner, there are n plus 2 couples or 2n plus 4 people in the party. Among these 2n plus 4 people, there is a person, let's call him X, who has the most number of handshakes. X shook hands with everyone except his or her partner. That means X shook hands with 2n plus 2 people. As everyone shook hands with different number of people, the handshake number ranges from 0 to 2n plus 2. Let's say Y shook hands with 0 number of people, which implies that X and Y are couple. Now if we remove this couple from the party, we will have n couples excluding you and your partner. If we no longer count the handshakes involving X and Y, everyone's handshake number will drop by 1, including your partners, as X shook hands with all the 2n plus 2 people remaining here. Now let's assume that the hypothesis is true for n. That means when you invite n couples, your partner shakes hand with n people. But when X and Y were in the party, your partner shook hands with one more person, that is X. So that implies when there were n plus 1 invited couples, your partner shook n plus 1 hands. That means our hypothesis is true for n plus 1. So we just proved that when the hypothesis is true for n, it is also true for n plus 1, and we are done. In your specific case, as you invited 10 couples, your partner shook 10 hands, and this is our answer.